Hello everyone. So on this video we're going to go over the most important points in chapter 5, which is about the compensating wage differential. Before we start, let me first go over the most important points that we covered so far since the beginning of this course. So before this topic, we assume that we have a perfectly competitive labor market. We also discussed the supply of labor, we discussed the demand for labor, and we discussed the equilibrium, right, in the labor market, where we have here the wages and we have here the number of people employed. We have the supply, which is positively sloped, right? The higher the wage, the higher the number of people supplying their service. We also discussed the demand, which is negatively sloped, saying that the higher the wage, the higher the cost of production and the lower the demand by firms. So we said the demand, we can also call it the value of the marginal product of workers, right? We also said that this one is basically the price that they sell the product for multiplied times the marginal product of worker. Okay, we call it the MPE. Usually we call it, like in macroeconomics, we call it the MPL, marginal product of labor, but here since we have leisure and we don't want to confuse leisure with labor, so it is called MPE for workers. All right, and then of course this is the equilibrium point. We discussed the point of intersection, W star and E star, where this is the optimal level of employment in the economy with this optimal level of wages. In this economy, it's perfectly competitive, right? So it's a perfectly competitive labor market. And in this perfectly competitive labor market, we don't have any unemployment, right? Everyone looking for a job is finding a job. We have an equilibrium. We don't have any shortage. We don't have any surplus in the market. We said we have only one type of work. We have identical jobs. We have identical workers. So this was like the environment that we had over the last 4 chapters. In this chapter, we're going to break some of these assumptions. We're going to start to make it like more realistic, because actually in real life, it's not perfectly competitive labor market. We don't have identical workers. We don't have identical jobs, right? Pay is not just one rate. So we have workers differ, we have jobs differ, we have pay differ, right? And jobs are not only paying wages, but they also pay benefits, and we have risks attached to different jobs, right? We have non-monetary aspects of the job, and so there are things that are more realistic in the labor market that we need to take into our consideration. So when we talk about the labor market, I'm gonna write it MKT as market equilibrium, is a function of the job characteristics, right? So it's not just that simple, but it depends on job characteristics. And different jobs have different characteristics, and accordingly, workers would ask for compensations. So the topic of this, the topic compensating wage differential, which is the title of our chapter, is basically how to compensate workers for non-wage characteristics on the job. So it's actually compensation, or compensate workers for non-wage characteristics on the job. Okay, so we have some jobs that are safe, right? We have other jobs that are risky, and the utility of the worker would depends on the risk attached to certain jobs. Not only depends on its wage, like utility depends on the wage, but also depends on the risk attached to different jobs. So that brings us to the introduction to, I'm sorry, where is the introduction to our chapter? So we said labor market is not characterized by a single wage. No, we have multiple wages. We can have different workers. We have different jobs. Okay, and as I said, um, Adam Smith proposed the idea that job characteristics influence the labor market equilibrium, or as I just wrote it here, labor market equilibrium depends on job characteristics. Different job characteristics would have different equilibrium. So compensating wage differential arises to compensate workers for non-wage characteristics on the job, right? Workers have different preferences, and also firms have offer different working conditions. They can have safe or risky working conditions. Some workers prefer risk and some others are risk averse. Okay, so we're gonna have like two types here and two types here, and we're gonna kind of match the person who likes the risk with the firm that offer high risk, and vice versa. So when we talk about workers, okay, they're going to choose between two different types of jobs. Either it's safe or it's risky. So their utility, their satisfaction will not only depend on their wage but also on the risk of injury. So of course, the higher the wage, the higher their satisfaction. So this is a positive. But the higher the risk of injury, the lower is their utility. So this is negative. So when we talk about indifference curve, we're going to talk about different combinations that the worker is going to choose between wage and risk. I want you to recall that we discussed before an indifference curve where we had, if you remember, we had here consumption and we had here leisure time, right? And we said they're going to choose different combinations between consumption. When you think of consumption as your spending or your wage, right? So you can have like this as your wage, you can think of consumption as your wage. So they're gonna be like looking at different combinations between wage and leisure time, right? Such that they are satisfied, they're happy. Like someone would prefer more to work more so they can get higher wage, and others would prefer, no, I'm gonna relax more and get a lower wage. So different workers have different preferences, and the combination here, or this one, was in chapter 3 between leisure and wage. Now our indifference curve is between wage and risk, right? So it's like you're gonna have here, this is the wage again, but this one is the risk. It has a abbreviation as N, noise. Okay, noise on the job or risk on the job. Okay, so of course the higher the noise, right, this is bad for the indifference curve, but the higher the wage, this is good for utility. It increases utility. The higher the noise, it decreases utility. Okay, so they have different combinations. So you can think of the combinations between wage and probability of injury as we can have it in a set of indifference curves. So for example, this is a probability, and you know from a statistics course, whether in your high school or college level, that probability ranges between 0 and 1. Nothing happens, or 100%, everything that can happen. Okay, so it's a ratio between 0 and 1. So if we think about a worker who earns a wage of W0, okay, so this is the W0. So this worker would prefer a safe job because the probability of injury is zero. So at the probability of injury zero, this worker is earning W0. Okay, if this worker prefers a risky job, prefers mean going up, preference means like moving up to another indifference curve. If she prefers the safe job, then if the risky job is paying W1, it would prefer a risky job if that job is paying W1 double prime. So what does that mean? So if I'm comparing between this point and this point, we are on the same indifference curve. So if we are keeping utility constant, if you're keeping preferences constant, then in order to be at this point, right, and accepting a probability of injury of 100%, then you have to offer the worker W1 hat. Okay, so the W1 hat, or the difference between W1 and the difference between um, W1 hat and W0 is actually how much I need to pay more for the worker who used to be at this point with zero probability of injury, now moving to one probability of injury, holding utility constant because we are on the same indifference curve. So this is the amount you need to bribe kind of the worker, right, to accept a probability of injury of 1. Okay, this is a higher preference, which is W1 prime. If the worker is here, then this is a higher preference, and again higher wage. Okay, so you can think of the wage differential. This is what exactly the topic is about. The change in wage, or the wage differential, is basically the difference between W hat 1 minus W0, which is the difference between a job that has a probability of injury equals to 1 versus a probability of injury equals to 0. So this is how much you have to bribe the worker to accept being in a high probability of injury or high risk job. This is what we call a reservation price, or the reservation wage. This is the minimum that the worker would get in order to change their mind to join the high risk environment or high risky job. So in order to determine the wage or the wage differential, okay, so we have a graph here that has W1 minus W0, which is the amount of compensation that you need to offer in order to the worker to start supplying their service in the risky jobs. So this graph is just about risky jobs. Okay, so there is a certain minimum. Of course, it can't be 0, because if it is 0, then nobody's gonna go to the risky job. But there needs to be some gap that is non-zero, right? So the minimal gap is going to be our intercept here. And as this gap increases, workers are going to supply more and more and more and more of their service in the risky jobs. In other words, the higher the difference between the wage you get in a safe job versus a risky job, the more your willingness to supply more hours of work in the risky job. Okay, and this is the maximum. So the theta here, and the theta is basically the difference in the value of the marginal products of the risky versus the safe job, right? So the value of the marginal product, the difference between these two is denoted as theta. So I want you also to check your textbook for more details about the theta, and it's very important, and it's discussed in page 186 in chapter 5, and it has more details about this theta and how it is derived as the difference between the value of marginal products in the risky versus the non-risky job. All right, and of course, as the differential between marginal productivity of workers in the risky versus non-risky decreases, then the demand is going to increase. Okay, there must be a certain point where we have an equilibrium. So the equilibrium point is at point P, where there is a gap or wage differential gap star, which is the optimal point, and there is an employment star. So there is a certain or a special case when we have some workers who prefer risky jobs. You can find some workers who actually like to take risk and prefer risky jobs. So if we complement this with firms that have a low demand for these workers, then we're going to accept a situation where we have wage differential that is negative. Okay, so you have some workers who prefer risky jobs, but actually there is small demand for it. So if there is a small demand for it, then those workers are actually kind of paying to be in the job. So there is a compensating wage differential is negative. In other words, the job that is safe is paying more to the worker than the job that is risky. Okay, so when we go under the zero, this part is negative. So if I'm saying the wage differential is negative, this implies that the wage in the non-risky job, right, exceeds the wage in the risky job, or the job that has probability of injury equals to 1. Okay, so at point P, it's a point of equilibrium where we have the supply and demand intersect, and this is basically the number of workers employed here are E star, and they're actually earning negative gap, or in other words, they're actually earning less than those workers who are in the safe jobs. So out of the previous slides, we can think of wage and risk as two goods that we can find a combination between them that achieves the highest amount of utility for the worker. Okay, we also going to talk about ISO profit curves, which are upward sloping, and it's again between hiring workers and the environment, or the risky environment. So we're going to talk about concave, or the shape, and the law of diminishing returns. So hedonic wage function, which is the topic of this slide, it's actually the relationship between wages and job characteristics. So in difference curves, as discussed in one of the chapters, one of the chapters before, we discussed indifference curves. There is nothing new in this slide. We already said that the steeper the indifference curve, right, then this person is very risk averse. Okay, worker C, for example, is just the opposite of worker A, does not mind risk at all. So how can we see this? So if you find the probability of injury increases by 1 unit, and versus this person, I'm just assuming that my hand is drawing the same exact distance here and there, just Imagine. And then like here, this person to accept a movement for, let's say, I'm just saying this is from point 3 and it increases by 1 unit, let's say, just an example, to point 4, for this person to, or for person A to accept the movement from point 3 to point 4, you have to pay him this amount to bribe him to take the job. This person has a flatter indifference curve, and as you can see, if we go all the way here, the difference is going to be just the minimum, right, compared to person A. So this person does not mind risk, does not have to be really bribed by a high amount to convince him or her to increase the probability of injury. But this person is risk averse. You have to bribe more, or you have to pay more in terms of wage for the person to accept, right, an additional unit of probability of injury. And this person is the one in between the two. Okay. For the isoprofit curves, so we have here again the wage and the probability of injury, so there is nothing new, and there is a profit function, right? We call it ISO. ISO means equal, right? So ISO means equal, and these, each and every curve is showing an equal profit. Each and every point is showing the same amount of profit. So if this is just an example, 200k profit, then this one and this one and this one, each and every point on that isoprofit curve is going to give the same amount of profit. Okay, so of course, the higher the probability of injury, the higher the profit. Why? Because the firm does not have to pay in additional cost to ensure safety measures, right, on the job. If the environment is risky and the firm did not take any measures, then it's trying to minimize its costs. If the environment is risky, the firm should take measures, right, in order to, or spend more in order to ensure safety for the work environment. So this one is telling us, you can imagine of this one, yes, it's a positive relationship between wage and probability of injury. The higher the probability of injury, that means the firm is not paying cost or additional costs in order to ensure safe environment, then it's kind of reducing costs, saving their money, and that means higher profit. Okay. Of course, higher wages implies lower profit. So you can think of it as the profit is a function of wages and probability of injury. Let's call it N for noise. Of course, the higher the wage, the higher the cost of production, and the lower is the profit. So this one is negative. This one is positive because the higher the probability of injury, the higher profit, because the firm is saving their money, right? So let's take it step by step. So P, Q, R, the 3 points give the same amount of profit. Okay, showing a positive relationship between wage and the probability of injury. Okay, so going this way increases profits. Why? Because going this way, I'm reducing wages and it has a negative relation. If you reduce this, then this one would increase. It's a negative relationship. But also if you move this way, right, then you are actually increasing risk, and as you increase risk, also profit increases. So the shift from indifference, I keep saying indifference, isoprofit curve I should say, the movement from isoprofit pi 0 to pi 1 implies higher profit. Okay, so higher isoprofit yield lower profits. Okay, Okay, so this one is the higher, it yields lower profit, or this one is the lower, yields higher profit. Okay, so let me stop here and I'm gonna continue in the next video.